Good afternoon, everyone. I'm
Hi.
happy to be here.
Some of them is a good
Yeah.
morning.
So,
It's
good
about
morning. Sorry
morning.
about
Yeah,
that.
7 o'clock.
Yeah. It's afternoon in California. So, so I'm going to sort of switch gears here. You know, I'm working, I don't know if you heard yet, from your team that I work for Cal OSHA, which is our state occupational safety and health agency. And we have it's primarily an enforcement agency that sets occupational safety and health standards, and then has an enforcement operation that enforces those standards in everywhere in the state where anyone is employed, basically. And the agency issues citations for employer violations of our safety orders and can bring civil charges against employers where there is willful violations of the safety orders and someone is um, seriously injured or killed on the job. And, every day in California, there's about 3 or 5 people who die in workplaces. Just from accidents, not, from trench collapses and falls and so forth. But then many, many more are exposed to toxic substances and have, long-term health effects from those. So my job at Cal OSHA is in research and standards. I am looking at emerging occupational health problems in California and developing strategies for Cal OSHA to respond to those through regulation. And so I'm going to talk about a case study today that has to do with primarily immigrant workers who have come into California and are fabricating countertops from engineered stone. And we've had an epidemic of silicosis among these workers. And so I'm going to talk about what that is, what we're trying to do as a state agency to respond to that. And then I want to open it up to you to think, given this sort of situation as I've described it, what you think we should be doing. Because we really are right at we're at the beginning of this thing, and we're trying to think through what can we do as a state government to protect this very vulnerable workforce. Um, and so I'll turn it over and ask for your help on that. So let me share my screen.
So I really know a lot about Cal OSHA. So that means every state has their own OSHA, so their own regulation state by state.
There are 23 of the 50 states and territories that have their own state OSHA program. And the other 27 are under federal OSHA. And so the only requirement of the states is
Mm,
that our regulations be at least as effective as the federal standard.
okay.
And as it turns out, as you can imagine, California is decades ahead of the federal standards.
Mm,
In we have multiple standards for all kinds of things that there's not even a standard at the federal level. And then where we do have a matching standard, our protections are much more modern, basically, and are continually revised and updated. So California is really with maybe 1 or 2 other states, is really the leading state when it comes to worker safety and health through our Cal OSHA program. So, and of course, it's being defunded at the federal level by the Trump administration now, but so far we're not affected by that. Does that make sense?
Yeah,
Okay.
yeah, thank you. So there's a federal OSHA, and then under the federal OSHA, so you
hmm
said 27 state OSHA, and then they do their own OSHA? That's what it is?
Yeah, 23 do their own
23.
state. Yeah, their own state OSHA program. And the other 27 have
They don't
just
have any.
they don't have anything. They just defer to federal OSHA. Yeah, I think so
Okay.
that's the main, yeah, that's the main thing.
Okay,
Um,
great. Thank you.
yep. So, okay, so this is what we're talking about. This is a artificial stone or engineered stone. So if you walk into IKEA, this is what you see all through the whole kitchen and bathroom show areas are these very kind of fashionable countertops. And you look at them and it looks like pretty cool stuff. When you look at how these are fabricated, this is the backstory. This is a photograph from Dr. Jane Fazio at UCLA. And these are photographs of artificial or engineered stone fabrication shops. And what you see here is high levels of dust. You can see on this photograph, all that white powder. That's dust from cutting and grinding and basically fabricating these countertops into, kitchen counters and bathroom counters and so forth. And so here's what these workers do. This is called, they're creating this bullnose edge, which is kind of that beveled edge with this grinder. Here's another one. This is dry edging. So you get, again, this beveled edge, so it's not quite as sharp. And another one is dry polishing. So this is a high-speed polisher. It gives it that sheen, very high, that shiny look. All of those tasks generate a lot of dust. When you look at it, what's happening is the dust that comes off of those tasks contains respirable crystalline silica. And these are these very small particles. This is 4 microns. What you're seeing on the left side of the screen is, these just little measurements showing a 4 micron size particle, 9 micron, compared to table salt, basically. So table salt in the right-hand side showing 100 microns. And so basically these are they're tiny particles, and many of them are actually smaller than 1 micron. And so what happens is when you breathe them in, they travel with the airway, and they get entrained with that airstream, and they land in the deep lung. If the particles are a little bit bigger, what happens is when you inhale them, their momentum causes them to impact on the back of your throat, essentially, or the larynx, as it's called, and so it lands in the tissues of your respiratory tract. But the very small particles that are 4 microns and then smaller than 1 micron, submicron sized particles, they're so small that they travel with the airway just like a little boat in a river, basically. They travel with the airway all the way down into these little, what look like nodules. These are the alveoli of the lung. And you can see on this little blow up that this is where oxygen and this is where air and blood exchange oxygen, essentially, where the lung transfers oxygen across the membranes into the bloodstream. And so these particles are so small that they end up inside the alveoli, inside where that diffusion is taking place, where oxygen is trying to get across into the bloodstream. And these particles are basically, they're little rocks, and they have very sharp edges. They are like, they're basically, if you think of them like as almost like a little tiny piece of glass. And so what the body does is it tries to get rid of those particles by it surrounds there's something called a macrophage that comes and surrounds those particles to try to get rid of them. And these little silica particles are so jagged and sharp that they break the macrophage cells, and it spills basically acidic material onto the surface of the alveoli and creates scarring. And you can't diffuse oxygen across the alveoli through that scar. And so what happens to people as they breathe in respirable crystalline silica, this is on the left side of the slide. You see this RCS exposure. They get lung inflammation down in the deep lung. That leads to lung scarring. And the lung scarring ultimately leads to respiratory failure. And when it becomes extensive enough, basically, you have large swaths of the lung that no longer breathe, essentially. They don't allow oxygen to pass into the bloodstream. And so people get short of breath, short of breath, short of breath, and eventually they are essentially drowning, and they can't get enough oxygen, and they die of respiratory failure. We are now, this is from last year. These are cases of silicosis as of December 2024. And these are individuals who have silicosis and have worked as countertop fabricator workers with artificial or engineered stone. You can sort of see the trend here. And I'll show you the up-to-date picture shortly for 2025. But we're on the beginning of an escalating curve of cases of silicosis. And so when you look at these cases, they are all young immigrant workers. And I'm just looking at sort of the demographics here on the left side. 100% of them are men. Their median age at diagnosis was 45. 98% of them are from Mexico or Central America. 13% received workers' compensation. It's supposed to be 100%. And most are reliant on public insurance, or they are uninsured. This is important because this is what we think of as a vulnerable workforce, essentially. They're not represented by a union. Most of them do not speak, the great majority of them do not speak English, and they're new immigrants. They don't know how, like, how does Cal OSHA work? They don't, and they're not going to complain about their working conditions, is what it comes down to. On the other side of this, what you see is that this is the artificial stone or engineered stone demand and what's been happening over the last 10 years or so, and kind of where it's going. So global demand for artificial stone countertops is projected to increase about 5% per year leading up to 2028. And so this is now the most popular product on the market. It's like if you go into IKEA, this is the only thing you'll see in there. It's all artificial stone. And it's really dangerous to work with, to cut and grind and so forth. So here's the problem. It's has very high silica content, so 93% or greater. So that's where you get those tiny particles that come off and land in the deep lung. When you cut it, it produces these very high concentration of ultra fine particles. They're less than 1 micron, less than actually 0.1, I guess I should say here. And so that makes them uniquely toxic to the lung. Those particles get all the way into the deep lung where they inflict damage. It also means that there's a large reactive surface area. They enter the deep lung. Those particles have irregular shapes, sharp edges, and fractures. So they basically are like, you could think of it as, like I said earlier, glass particles inside the lung. And that increases the rate of cell lysis, which is basically the destruction of the cells in the lungs, and that leads to lung scarring. There are also these volatile organic compounds that come off from the resins when you cut this product, because basically what it is, you can think of it as it's basically like sand that's glued together with a resin. It's like, except that it's basically silica particles that are glued together and shaped into a counter. Yes, question.
So how long were we talking about how long they are working with that? Only one time or what months? Because they're all of this scary
Right.
measurement. What they didn't say anything to say how long they're
Right,
working.
exactly. Great, great. Yeah, great question. Key question there. And it's like, how long are they exposed? And I'll actually tee up a study about that. Because what we're seeing is often when you see someone with silicosis, and that's the disease that I'm talking about, where they have pulmonary insufficiency from breathing silica dust. You see it in people who work in quarries or coal mines, for example, or they work with concrete. They cut concrete all their life, and they get silicosis at like 65, age 70, 75. It's at that you often silicosis is typically a disease that happens at the end of your life. And what we're seeing is that the median age for these workers is 45, and some of them have only worked with engineered stone for 5 years, and they're developing silicosis. And so what that says is this is a uniquely hazardous product. It's not like regular silica. It's a particular type of silica that's uniquely dangerous. And so this is sort of underscores this point. This was a study by Wu in 2020, and he had 18 patients with artificial stone associated silicosis. They were only exposed for 6 years. That was the median. A quarter of them, 22%, experienced a rapid deterioration in 6 to 12 months. So basically, they started getting very short of breath in a very short amount of time. Within 6 to 12 months, 40% of them required a lung transplant. 28% died of silicosis and what is called basically pulmonary insufficiency. They couldn't breathe. That's what it came down to. So Wu compared those to 63 patients with natural stone associated silicosis. And what he found was that the median exposure duration was 30 years. It took them 30 years of exposure before they developed silicosis. Only 3% required a lung transplant, and there were no deaths. None of those, they had silicosis, but they didn't die from it. They had shortness of breath. So their conclusion from this was that this is a very toxic product. These particles are uniquely hazardous. Okay, so those are a lot of numbers. So this is Juan Gonzalez Morin, and he developed silicosis after cutting and grinding artificial stone countertops. He was making $14 an hour. He worked for about 8 years in LA, and he said, many of us continue working in this field out of necessity, and many continue because of ignorance. I told my boss what was going on. He said he was very sorry. He said I should go get a job at Uber. They make good money there. He died in April 2023 at age 37 of silicosis from working with engineered stone. This is Gustavo Reyes Gonzalez. He's 32. He's a father of three, and he came to the standards board that is the board that passes or approves of new regulations in California. For our emergency rule on this, he had a severe case of silicosis. He said he used water to suppress the dust. He wore high quality masks, but the fine silica dust still entered his lungs. He received a lung transplant in 2024 that could extend his life up to 10 years. That's what it says here. So he's 32. And then this is Jane Fazio, who and her colleague Nadir Kamangar at UCLA Olive View. And she has been really leading the investigation and treatment of these patients. She says, I have numerous other patients in their 30s on the lung transplant list, waiting and waiting for one of those precious organs to become available and become a match for them, but they don't come available that often. A lot of them will probably die waiting, and they're terrified. And then finally, this is Mark Marzek, or Marek Marzek, who worked for 10 years, again, and he's 48. He's a father of three. This is in London, and he's dying of silicosis. This was in November 6th of last year, and he's probably not alive now. He had about 6 months to live. He called for urgent safety changes to prevent others from dying after simply doing their jobs. When we took a look at this industry, we sort of we wanted to understand what is the kind of structure of this industry, what's happening out there, why are these workers getting so sick? And so in 2019 and 2020, we launched this SEP, which is a special emphasis program, to go out and look at these shops. And we found that about 72% of them were in violation of the state's silica standard. There's actually a standard that we have for that was like, you're supposed to protect people who are cutting stone, essentially, with these various protections. Only 5% of them had received a required medical exam. Every one of them was supposed to receive a medical exam because the early symptoms of silicosis are not detectable by the patient. You don't know that your lungs are basically being destroyed. You don't feel it for a while, but you can see it with an MRI. You can see where sections of the lung are damaged. But you can only detect it through a medical exam. But only 5% were getting medical exams. So basically they were developing silicosis. And by the time they went to the doctor because they were having shortness of breath, it was really too late. Only 45% reported using wet methods. And this is, where if you sort of submerge the product in water and cut it, that will reduce the dust exposure. So basically, when we looked at this, what we saw all around the world was that workers in this industry, about 12 to 21% of them were getting silicosis. We now know that it's actually about 25 to 35%. It's kind of a disaster that's unfolding here. And the silicosis fatality rate is 19%. And so right now, we'd estimated there's about 4,000 of these workers in California. At least a quarter of them are likely exposed over the permissible exposure limit. This is so after a median of 15 years of exposure, we would expect 19% will die of silicosis of those who develop silicosis. And we're also thinking that they're estimating there's about 4,000 of these workers, but it might be as high as 11,000. So, it's a wide margin. But the point here is that we're expecting that on the path that we're going, between 500 and 800 of these 4,000 workers could develop silicosis. And about 95 to 150 of those could die of pulmonary fibrosis and respiratory failure if they didn't get a lung transplant. It's sort of an unfolding occupational health disaster. And so this year, as we've gone out, we opened 92 inspections at these facilities. We've closed 72 of them. That means we've completed them. 93% were in violation of our new emergency standard that we put in place. So this is an industry that is working with a very toxic product, and they're sort of widely out of compliance, with the regulation that's supposed to protect workers. 24% of the shops were ordered to shut down on the spot. That means they were issued an order prohibiting use by Cal OSHA, meaning that they basically closed the door of the shop. They told everyone to go home. They closed the door of the shop and they taped it closed. And they said, no one can go into this shop until these hazards are corrected. And that happened in almost a quarter of the shops because the conditions were so bad. So this is kind of uh, from one of the senior industrial hygienists at Cal OSHA. She said, I'm averaging about 10 citations per countertop inspection. Other co-shows, that's the compliance, safety, and health officers I have talked to, are finding similar results. Even cutting wet, they're still over the PEL, or the permissible exposure limit for silica. By issuing orders prohibiting use without having to do sampling, she said, we can stop the exposures immediately. We're also requiring a higher level of protection for those workers once the shops do reopen. So Cal OSHA is trying to get out there, and I won't go into the just in interest of time. I'll just sort of touch on what we've done about this, and that is that we issued an emergency regulation that basically said, if you're working with artificial stone that's more than 0.1% silica or other silica-containing products that contain more than 10% silica, you are doing what we call a high exposure trigger task, and that sort of triggers a whole set of requirements. And so if you're not using artificial stone, so basically all other stone products, it's not a high exposure trigger task, and you sort of comply with these pre-existing Section 5204 requirements. And so basically we've created a unique regulatory framework for companies for these fabrication shops that work with engineered stone. So here's all the things that it does, and I'm not going to go into these, but these are, it's like each one of these is a subsection of this regulation that basically requires the employer to use a lot of water anytime a worker is cutting this material, and to use a very sophisticated respiratory protection called a powered air purifying respirator. Under medical surveillance, every worker is supposed to have a medical exam for silicosis. And if they have any signs of silicosis, they have to be removed from their workplace, and they have to be paid for 6 months until they can get another job, basically. So there's a lot of requirements. If you as a business owner want to open a shop and make engineered stone countertops in California, and it's the only state in the country that has done this, you have to follow all of these requirements to protect people. So that sounds all good. And this is a little blurry, I apologize. But here's the situation. We have this new regulation. We put in an emergency rule in 2024. We made it permanent. We made it even stronger in 2025. But right now we have 346, I'm looking at the top left of the page here, 346 confirmed engineered stone silicosis cases. As of today, that has now, the 19 deaths has gone up to 21. We're expecting that about 20% of these cases, these 346 cases, about 20% of those are going to die from silicosis. More than 60 people. This is 100% preventable. That's the tragedy of it. So you see the median age where they were diagnosed with silicosis was 46. The median age at death was 1 year later. Pretty shocking. 99% are male, 99.7, and 98 are basically from Mexico and Central America. And these are in the bottom left here. These are the last known transplant status for confirmed engineered stone silicosis cases. You see that's like the number of cases, and then across the bottom it says underwent lung transplant. There's 41 people. Each one of these procedures is between $1 and $2 million for a lung transplant. And these are uninsured workers. And so what's happening is those procedures are being paid for by the state. And so basically the industry, the engineered stone fabrication industry, has employees who are working with this very hazardous product, and those employees develop silicosis, and the employer offloads the cost of their care to the taxpayer. So basically, California citizens are paying for these lung transplants. And then there's maybe like 5 who were found ineligible for lung transplant, meaning that they were so far into, for one reason or another, they were not found eligible for a lung transplant. And so those cases are not going to survive. And so here's what's happening. If you look in the bottom right, this is the cases, the number of cases from 2005 leading up to 2022. And then if you look at this top right, you see you can see that in 2025, we're at we're almost at 100 cases, and we're basically, let's say we're at August 1st. We still have 4 more months to go. 4 months, August, September, October, November, December, 5 more months. We have 5 more months to go, and we're closing in on the total amount that happened in 2024. So you can imagine that this is, going to continue the curve here, basically, by the end of 2025. Do you think, and now I'm going to just ask some questions here. So if you look at this graph, like in the bottom right, it takes somewhere between 5 and 10 years before someone actually develops silicosis. So these cases that we're seeing in 2023, they happened back in 2013 or maybe 2017 or 18. They happened back in the 5 to 10 years before, and now they've turned into silicosis. Where do you think this? We put in a regulation to protect these workers in 2024, and we made it a permanent rule in 2025. Do you think that's going to drive down the case numbers? Where do you think this curve is going to go? Given that it takes 5 to 10 years before you start seeing these cases, there's a latency period, a disease latency period. So is this curve going to, we put in this rule, let's say 2025, are we going to now start to see a drop in cases? Or will the case numbers continue to grow?
I think the case numbers should continue to grow for about 10 years, and then they should start to drop off as 10 years has passed from the regulation update.
Right. It's sort of like, okay, we're basically at the beginning, we're at the early stages of this epidemic because of the latency period. And so the question is, we're finding 90% of the shops that we went out to be out of compliance with our new standard. They're basically, there's basically widespread non-compliance. And we're hearing from LA County, for example, when they go out and look at shops, the protections just aren't there. The employers, they're not using wet methods. They're not using respirators. And, part of the problem is that these are small shops and the protections are pretty expensive. And so looking forward, I think, Ryan, to your point, if we stopped the exposures today, we're still going to see cases for the next 10 years. And, basically young men dying of silicosis in the next 10 years. And so what we're trying to figure out now is, okay, what do we do about that? This month or next month and in September, we are going back to what's called the California Occupational Safety and Health Standards Board that's appointed by the governor with a recommendation. We want to make a recommendation to them on what else we can do to drive down these cases. So we put in an emergency rule that requires wet methods, and special respirators, and special cleanup procedures, and medical surveillance, and all these things. Doesn't look like very many people are doing it. We're trying to enforce it. We're not going to get into all 800 shops. So what else can we do? And we're actually grappling with this right now. What else can we do to drive to like protect people today, even knowing we're going to have cases for years to come, but we could do something. Maybe we can do things to protect so we don't have cases for the next 20 years or 40 years. So I guess I'm going to put that out there, as a question is what if you were to think about, this industry that's kind of small little fabrication shops where they're cutting and grinding these countertops. The median number of employees is 5. So these are small shops. They're distributed around the state. There's an underground element of it. Many of these shops are not licensed. Many of the workers are undocumented. They're certainly not unionized. And so, and the demand, like I showed earlier, the demand for this product is growing 5% a year. It's the most popular countertop product on the market today. And people are basically dying to making these countertops. So if you were to, put on your thinking cap and, like if you were to sort of give us some advice on what do we do as a state government to protect these people? What kinds of things can we do beyond having written and passed regulations? What other things do you think we can do?
I was thinking about like ways to spread awareness about this issue. Because on the one side, I'm sure that a lot of the workers may start working without the knowledge that this is like extremely fatal and they will probably die in like the next 10 to 20 years. So I'm wondering if there's a way to really get the word out there that this is a very dangerous job and kind of these are the statistics. Also, you mentioned that almost like 98% of these cases are Latino, so like a language barrier might be another component. And on the other side, telling consumers that, hey, like this, the manufacturing of this product is harming a lot of people, and it's not just harming this one person, it's harming like the people close to them as well. So obviously you can't say don't buy this product, but kind of just putting it out there.
Yeah, so basically it's like raising awareness, educating both workers and consumers. And this is the California Department of Public Health is doing this. One question is, how do you reach those workers? A very practical problem. And I guess I'll ask, how do you? How do you reach these workers?
Is there any way as a government intervention is like state or federal? This is a kind of 5% is a large and they a lot of demand, but this is kind of not mandatory, how can I essential to live. So I don't know, it's radical because I'm old. So I don't think it's raise awareness is good enough for DACA and consumer. Consumers sometimes don't matter. I don't care. That kind of attitude.
Right.
They don't see behind the beautiful engineer, and that this is very cost effective as a customer. It's very cheap. It's a cheap compared to marble, but it's like
Mm,
very sturdy and durable and very practical. So if I
right.
am state or federal government, I'm gonna kill this industry. I'm gonna just close down to this.
Yeah.
Yeah, this is not how can I it's not worth it to do it.
Hmm.
So all the customer, if you do have a money that go to the marble, if you don't have any the money that go to the wood or plastic, whatever, is
Hmm.
there is a
Hmm.
substitute enough that we can choose from? Why we kill workers to do have a very niche market and then
Right.
satisfy for consumer?
Yeah, I think, I hear your point that this is not an essential product. It's basically, it's like it's a fashion product. It's like, it's a countertop. There are alternatives. And so why are we killing people to make a non-essential product, for which consumers could choose something else? And so you're calling for a much more government intervention, basically, into the market.
Right, extreme intervention.
Yeah, extreme intervention. And what and the other suggestion was more sort of education and awareness. And so let's take each of those in turn quickly. I think one of the education and awareness is always a good place to go, and it is always also fraught with weaknesses, and sort of fraught with problems. And one of those is that it's like looking at the workforce that is working with this material. They're new immigrants. They very few of them speak English. Very few of them speak Spanish. Actually, many of them speak an indigenous language from Latin America. So they're they're they don't have agency in terms of their ability to control what happens in their workplace. They they feel lucky to get a job, and if their employer fires them, they have to figure out how to get another job. And they probably got this job because of a friend that helped them, and it's kind of their lifeline. If they lose their job, they lose their income, they could be homeless. Their life is on the line, basically, and that's why they have this job. And so and this is happening right now, the state health department or LA County Department of Public Health comes in and says, hey, this work is super dangerous. Working with this stone, you're going to get silicosis. Their sort of response has been, yeah, but it's a lot better than being homeless. I'll take my chances, almost without exception. They're sort of like, I'm willing to take this risk. And it has been the story of immigrant workers in the US for 150 years, 200 years, where they're working in the most hazardous jobs, and they're kind of trapped there. And sort of no amount of education or awareness is going to change that. They can't sort of up and decide to go work in construction or work somewhere else. And so we're finding that we don't get very far with that. But then your other suggestion is this idea on the consumer side. Can we drive down the demand by educating consumers that this product is really deadly for the workers who make it? And I think your point about how it's so hard to get through to consumers. Like, how do you educate consumers? What do you do? Do you put up billboards? And do they care when it comes to like they've made this calculus? This is a nice product. It's inexpensive, and I need to build my house and put in these countertops. And is it really that bad? And then do you put up signs where they purchase it, and will IKEA put those signs up? I don't know. Juan, what were you thinking?
I think kind of my logic on the consumer side was that if people care about turtles and straws, they might care about people dying and
Mhm.
countertops.
Maybe. Yeah. Yeah. It's hard to reach them. It's hard to reach consumers. It's like you're doing it through a big sort of public education campaign or something. It's very hard to reach consumers. Uh, and so I think, there's been some efforts in LA putting on like on the sides of buses. There's been that. But the other thing about reaching the workers is that it's really hard to find these workers too. They're in these little shops. It's almost like the garment industry, has been in the US, where you have immigrant workers working in garment shops um, they're you wouldn't even see them. They're in the backs of warehouses. They're in these places, and they're very hard to find. Um, and this is where, for when workers have actually organized and they're part of a union, like they're in the textile workers union or they're in the bricklayers union or something, you can actually go to the union, and the union organization has access to all of these workers, and the union can distribute that information and get it out to them. And that makes all the difference. I mean, you can actually do a worker education campaign. Um, uh, but here you have a workforce that's not organized, it's not unionized, it's often in the informal sector. Um, but I hear the other sort of under the point you're making also, I think also is that the objective of that sort of consumer campaign is to drive down the demand for the product. I mean, is that part of it? Is that kind of what the objective?
Yeah.
Part of the problem here is that these shops are making these are engineered stone countertops because that's what Home Depot and that's what everybody's buying. And so there's money to be made, basically. And so here, let me take off this share here. There's money to be made. So there's this market out there that's just kind of going in leaps and bounds, and there's all people can make all this money selling these countertops to Home Depot and to IKEA and Lowe's. And Lowe's is demanding product. So, is there a way to drive down to reduce the demand? And I think, this is again sort of the point about, we're seeing people dying of silicosis now, and an education and awareness campaign can take a long time to get through. But what other strategies are out there if you were thinking through, like, so we've talked about education, awareness, or also state government intervention to prohibit the product, basically. It's the way
I have,
enter.
this might be also extreme,
Mm-hmm.
but what if we just said you can only work in these shops for a certain amount of years, preferably less than the latency years,
Hmm.
and maybe they'll drive away. I mean, if it's possible, I was hoping maybe because many come to these jobs for like it's like a lifeline. But if we set such limitations on the amount, like on the years they can work there, they'll
Mhm.
be kind of forced to go find a different avenue. And that would kind of, it's not awareness, but it would imply to them that you can't work here for this long because whatever,
Mhm.
whatever. I don't know. That was just a thought though.
No, it's an interesting thought. We hadn't even thought of that one. That basically there's some sort of registry or what have you that, like, the employer would have to know that, oh, they've been working in this industry for 5 years. I'm not supposed to hire them, or
Right.
they and
And
basically, yeah, they become ineligible to work in that
right.
industry.
And it can be just like a name and a face.
Mm-hmm.
And maybe more things can be added on, but I was, yeah.
Is
Yeah.
industry organized enough to see the name and face and then to check background, or because my thought is that we're not gonna care. They were not gonna
Mhm.
bother to check, and they don't have any organization or any effort.
Right. Yeah, and it's like it's thinking about is the strategy, does it actually match the way this industry looks and operates? Like maybe if you have a big company like 3M or you have Apple or something, and they know about who has worked and how long you've worked in that industry, and they could set a boundary on it. But I think, like you're saying, this is a very informal industry. And so they have these little shops set up, and there's 5 people working there. And sometimes they open a rental, like a storage unit, and they'll set up saws and everything in a storage unit. And they'll just be in there grinding and polishing and cutting, and they put it on their pickup truck and they drive off. And they take it to the construction site. So it's a very informal industry that has very little access to electronic databases and you have immigrant workers coming in who have no background. Okay, so that's kind of a, Jen, I think sort of as a sort of a high tech approach to limiting exposure, which is a good instinct. How do we make sure that people aren't in the industry so long that they're going to be harmed or killed by it? But it's also a mismatch for this industry, which is very low tech. They're basically a cutting stone, and they're just anybody that they can get in there to cut the stone, they'll do it. Okay, so yeah,
I think that's the Gen Z solution. Everything is connection, social network.
Yeah. Ryan, did you have a thought?
Yeah. So you were kind of mentioning that this material is a trend.
Mm-hmm.
And trends come and go, and so hopefully the trend will die out soon. However, I think that maybe think of the idea of just creating a new trend, preferably a more sustainable, safer trend that can hopefully become popular enough to limit the options for these workers, and maybe the workers can move out towards a different direction and a safer direction.
Mm-hmm. I mean, how long do you think it would take to sort of inoculate a new trend and get it rolling and sort of getting people to purchase it and so forth? Maybe you have a sense of that?
I'm not sure, but I'm just thinking as these regulations are rolling in for this material, that hopefully we can try to provide another alternative solution, so that there is a transition and it's not just these workers are just completely left in the dust right after these regulations hit.
Yeah. Yeah. So that's kind of a good segue. It's sort of like so you're sort of getting it to this point of, there's probably a safer alternative out there. And can we motivate the market to go in that direction? And so and I see that we're almost out of time. We are almost out of time here. It's 5 o'clock. So as of today, this morning, what we launched basically with the state health department is that we're going to pursue a ban on the use of engineered stone in California. And basically, Cal OSHA doesn't have the authority to ban a product, but we can prohibit its use. So you can buy engineered stone, but you wouldn't be able to cut it or grind it or shape it or you could hang a big engineered stone slab on the wall if you wanted, but it would be illegal to basically handle it in any way, to shape it or what have you, cut it and grind it. And we're basically looking at sort of what we're seeing as a occupational health emergency that's unfolding in front of us. And we're going to continue to see cases for years to come, that we have kind of concluded today that we have to intervene really concertedly into the market, and that we can't rely on the market to sort of respond to these cases of disease and death and self-correct over time. Like for example, by improving people's awareness and changing in their purchasing patterns and so forth, that the situation is so dire and the disease is so serious that we kind of feel like we have to intervene pretty aggressively into the market. And that, of course, introduces the question that Ryan, which is, well, then what's the alternative? And we're sort of seeing this as as a way to begin motivating basically the competitive advantage of safer alternatives. This is the engineered stone industry, the countertop industry is very entrepreneurial and innovative. And if once they see that this, California being the world's 4th or 5th largest economy, is moving down the path of prohibiting the use of this product, it opens the door for companies to begin basically innovating safer alternatives. It's a sort of regulatory technology driving strategy. And so we basically open the door for safer alternatives to have a foothold in the market, because the big competitor in the market is going to become illegal really soon. And so we're seeing that as a way to stimulate innovation. One of the downsides of that, you can imagine, is that the shops in California that are now, we've tried to regulate and protect these workers, they're going to move over to Nevada, or they're going to move into northern Mexico or Arizona, and they're going to set up shop there where there are no protections whatsoever. What we've decided is that if that happens, then we'll deal with it when it happens. And it becomes a question of interstate commerce, and the Attorney General will have to get involved. But our mission, our mandate at Cal OSHA is to protect California workers. And we can see right in front of us that California workers are getting sick and are dying from this product. And so it's within our jurisdiction to regulate and and hopefully we can take this action to prohibit the use of the product in its entirety across the state. Production might shift to another state. It might shift to Mexico, and we'll just have to deal with that when the time comes. But what our hope is that it will have an effect on the market. It will have an awareness effect also, that the public and workers will be sort of, made aware that, wow, this product is so toxic that it's actually banned for use in California. Wow. And that has an effect probably across the country. So it's both sort of a regulatory action that's, sort of government intervention in the market, but it's another way to think about it is to say, we are doing that, and we're also opening the door for innovation and for safer alternatives. And so there's a market argument for it in a way. This is what it comes down to, because it's like we might be told by the governor's office that we can't do this, that we can't prohibit it. And so we have the process of generating and promulgating a regulation it's not sort of, it doesn't just happen because it's a good idea or the science is good, or we have like these cases, we have people right in front of us who are dying of silicosis. Ultimately, in the end, it's a political process. And so you have to sort of think about it that way, that you have to be able to make the argument that the idea of intervening in the market and prohibiting the use of a product, it's going to put people out of work. It could shift production to other states. Yes, it will save lives, and those diseases are really expensive, lung transplants. So there's that. But in terms of, as you're thinking about your intervention, the governor is concerned about the state of the California economy. And so you have to be able to think through, like, how does this affect the economy? And can you make an argument that says, actually, this is a smart move when it comes to the state's economy, and that we are going to open the door for innovation in these safer products. We're going to save these workers' lives. We're going to drive down the cost of healthcare. And that's why you should support, this is to the governor's office, why you should support Cal OSHA's action to prohibit the product. But it's not as if we just write it and it goes into effect. We'll basically be told that, no, not going to do that.
Is the current governor what is it, Gavin Newsom?
Newsom, yeah.
Yeah, is it good? And then
he is
understanding the
good.
right. Okay.
He is good. He's really good. And he has multiple feelings at the same time. He wants to protect. Yeah, I know. I mean, his values are in the right place. I think we can say that he is, he genuinely wants to protect the health and safety of immigrant workers. And he generally wants workers to be safe in terms of workplace safety and health generally across the state. But he's also thinking about the impact on the state's economy and jobs and housing. Are we going to increase the cost of housing by doing this? Are we going to get into conflict with the industry and have a big confrontation between state of California and this gigantic global engineered countertop industry? And then he's in the middle of that, as the state's governor. He's now, and this is it's like a $15 billion industry. So his state will be stepping in the middle of that and say, oh no, you can't use that anymore in California. Ultimately, he has to really be convinced that it's the right move that has lots of benefits, along with this downside of a potential confrontation with the industry globally. So that's, as you're thinking about, your environmental and occupational health careers, and you're trying to protect workers in this case, it's sort of you'll need to develop your portfolio of sort of skills to understand, oh yeah, this could have an effect on jobs. It could have an effect on housing prices and all the things that like a legislator or a governor has to think about. The more you can do that, the more effective you'll be.
Right.
Yeah.
Thank you. Yeah, it's a three-dimensional. It's not easy. So
yes.
level.
Very well put. Exactly. Three-dimensional problem. And we, scientists, or, like health scientists, we have a very one-directional focus.
Right.
It's like people are getting sick and dying of silicosis. We're going to solve that problem. Hey, Betsy. So, but I don't want to step on Dr. Noth's time. So.
Hi, Mike.
Hi, Betsy.
Okay. Thank you so much. It was so good. I learned a lot, and then depth of thinking is really, really. I feel like I extended more. We can see more the products and behind the products. That's what I love of all these lectures. It's really extended all that perspective.
Great. Good. Well, I'm so happy to join you. I'm really happy to be part of your class this year.
Can you send us the slide that we're gonna up there with the recording and slides?
I will do it. I'll send it right now.
It was great. Thank you.
Thanks so much. Thanks, everybody. Great
Thank
questions
you.
today. You bet. All right.
Oh yeah, good news. I got the data for S4.
Oh, wow.
Yay.
From Megan, Dr. Schwartzman?
Mm-hmm.
Yeah,
She contacted me with the stati statistics
right.
of
Was
That's
that
right.
what Stella Beckman was? Is she the reference?
no, it
Or-
was Dr. Kirsten Knox.
Oh, okay. I know she's trying to connect you guys to somebody else
Oh
um,
right, for the women's breast
for the women
cancer.
for the women's
Yeah,
breast
yeah.
cancer. That's right.
Can
Yeah,
you
and
put
Stella's
it
great.
in the chat? Then Hound can put it in the reference.
What do you mean? The people's names?
No. All the statistics that you got.
Oh, it's in a CSV right now.
Oh, okay. Later, send it to
Um,
later, send it to Hound.
I will have to look into it. Can I just
Yeah,
open
later.
CSVs as Excel? I think I can.
Yeah, later. It's not important. It just don't forget that.
Okay, well that's
Uh,
great. That makes it a lot easier to do the summations and all that.
Yes, so that's great news. We ended up going off by threes for the list for the committee to look at. And I was a little really iffy on it, and I didn't want to wait to ask you, so I asked Dr. Schwartzman yesterday, and she said it seems
Cool.
fine. But also, like, I think it looks fine. So that's that. We got our two metrics in. Hopefully, everyone double checked like I asked. I have also come up with like a database idea, but I haven't actually implemented it yet. But we all have our total group emissions and our chemical frequencies for each of our groups. That is really where we are because we had our thing with Dr. Schwartzman yesterday and today with Dr. Wilson.
And so you're still gonna do total frequencies and you're gonna do total like methylene chloride for all the things that cooks and food preparers use, right? You're gonna do that breakdown. So that's still in the future. Okay. Cool. This looks like it's going well.
Yes. So yes, that is where we are. I think going forward, what we have to do is, I don't know if we want to look at the raw number of frequency or maybe the relative frequency. That was like one of the questions that I had. I'm still unsure where to use one for the others.
Yeah, I mean, there's a lot of, I guess I'm stuck in thinking that the quantitative amount of chemical used is better than the frequency it's used, since the chemical amounts can be really different. I'm not sure, like, the only thing I can think with frequency would be if something was ubiquitous and was really potent, then that would pose like maybe a high level of importance. You know, like if a lot of people are exposed to it, or if a lot of, well, no, we're not yet to people, but if a lot of products contain it and it's got,
Like general purpose cleaners.
yeah, if it's like something in general purpose cleaners and it's really potent, but I guess we're not really thinking about potency because we've decided we have our top chemicals and that we've made the assumption more or less that they're all equal potency at the moment because we don't have an outcome in mind. And so we're just looking at exposure. So I think that's, so then I guess in absence of, if we're imagining that the potency is all the same, then we just go for the highest quantity used, like the highest total pounds per day. Because all of these chemicals are on the top, on the tier 1, right? So
Right.
so I think that's why we're making this assumption. And at some point, I mean, we could look at the potency of these things, but the problem then is you have to decide what your outcome is. And these all have different outcomes. And so then you'll end up with one chemical that has a super high potency for, developmental, like teratogenic, effects, like that they harm the fetus during development, or you'll get another one that causes cancer in adults, or you'll get another, so it sounds like, how do you compare those things? And so I think that probably we should just stay away from health outcomes, that we just have to be happy and continue to remind ourselves that we are happy with the tier 1 like assignment, and that we're just going to pick equally like between those. So you could pick the highest frequency chemical for these different jobs. Yeah, you can either do that, which is already there, but I think that doing the summation of all the pounds of each chemical per day, especially now that you have the
Hmm.
the easier access to that, will be rewarding.
I think that was very helpful because I was also thinking about the frequency, and there's like so many things that frequency assumes, but also hides in its values. And I was like, that's
Yeah, I mean, I think that frequency is, I think once you have it in the pounds, you then could, if you wanted, wanted to decide something about the potency, but frequency won't get you anywhere further.
mhm.
Because people will do things like, if your outcome is cancer, then they'll put it all into equivalents of like benzoate pyrene carcinogenicity, and it can get really complex, and I think that the message can be lost if you get too complex. So I think that just saying pure poundage, and if something is enormous, if methylene chloride is a huge pound per day, like then you could think about, okay, like is this a different, like should we scale it somehow to, formaldehyde, which is, maybe less. I don't know. It's one of those you'll have to see. But yeah, I think it seems like it will work out. It seems like you have all the data now, which is great.
I know. She even gave us a R script to like if you want to look at it. So
Nice. Yeah.
yeah,
Well, it's cool.
very cool.
Okay, well then maybe you don't have any questions for me until you guys run through that and run through your committee. Do you have any committee questions?
I think for now, what our plan is meet tomorrow because by then everyone would have done their own assignments.
Mhm.
Then we'll have a consensus and all that. But I mean, this is far too late. But I was thinking maybe next time we'll do the committee a bit earlier down the work process than cramming it in the middle like this.
Well, you'll see.
But
Then the committee's work will then be done. So
all right, so then I think for today, I think this is big, like looking at the summation of individual missions, because I didn't want to use frequency alone to try to look into which jobs you want to look into, which groups of jobs you want to look into for the demographic information. So once we have the summation of individual emissions per chemical on this top tier list, we would probably look at the greatest per job or overall, or should we worry about that when we get there?
you'll probably want to do both. I mean, like I think that it'll be interesting to know, like globally, across all your jobs, what is the most used. And then it'll also be interesting to know, like, well, for certain jobs, is the top chemical really different because it's a different type of job? Like for all the like jobs that are in kitchens and maybe building cleaning, like maybe all of those exposures will be based on whatever's in general purpose cleaners. But then like maybe the automotive people will have a whole different set of chemicals that's, or a whole, not set because the set is fixed, but a different like sort order, like what's the highest poundage per day. So I think, or tons, I keep saying pounds, but it's tons per day. That, you know, I think that you'll have to just see. This is definitely discovery.
Hmm.
And there may be something, sometimes when you do these things, you find like something really compelling, like, wow, everybody's exposed to blah, 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 in at least 4 chemicals. Like that's not, or at least 4 products, that's not acceptable, or wow, this one chemical is only used in this one industry, but dang, that is a really high amount and we should move to regulate that. So I think like you can kind of choose your own adventure of what you think is most important. And the last thing that you'll do, or a subsequent thing you'll do, depending on how you think about it, is to add people information to the jobs. And so then that can be another way of sorting. If you decide, oh, we want to look at what um, is going to protect the most number of workers, then it'll depend on how many people are in each of these jobs. Or, we want to protect the most number of workers who are under the age of 30. And so you pick, so etc. So I think that you can draw different conclusions based on how you both what you see in the data and what you think is a bigger priority for protecting workers.
Yes, and possibly more I hope to think of.
Yeah, should be fun.
I have a one question. So, Mike said OSHA, California OSHA, and the 23 other state OSHA. Which state is the strongest one other than California?
I think some of the other ones that are strong, I don't know which is strongest, but Michigan, Washington,
State of Washington.
yeah, New York, New Jersey, probably New York, maybe Massachusetts. I'm not sure. That's a good question though. And it would depend again, not to be annoying about it, but how you define what makes an agency strong. You know, like if it's enforcement numbers or if it's something else. But I know, for example, with silica, which is an emerging sort of risk, California is the only one with a good dashboard. We're the only ones with a regulation. I know Michigan and New Jersey have things under development. So it all depends on how you measure it. And Michigan and New Jersey, certainly New Jersey would have a lot of countertop production, I think.
No, overall, not only countertop,
No,
because
no, I was just using that as like a measure of
oh,
like
I see,
how
I
on
see.
it they are. But I
Mhm,
don't know.
mhm.
I don't know really what the better other state OSHAs are that are good. I know that the ones around us are generally not as good. And Oregon and Washington tend to be strong politically in worker protection, but I'm not 100% sure how strong they are in their state plan, their OSHA state plan. I do know that Washington used to have an ergonomics standard, and so that gives me the feeling that they're sort of um, had been on the cutting edge and pushing things, but then it was also repealed. So I don't know what that means.
So
So
East Coast, how about East Coast, New York and New Jersey, you said? Massachusetts?
I I assume, but I honestly don't know.
Oh, okay. I will look into.
Yeah, yeah. Yeah, I mean, they have lots of people working in industrial hygiene and occupational health. So I would assume that all those New England states and probably North Carolina is pretty good because they have so much Fed OSHA in North Carolina that it
Mm.
probably spills over into being a good situation. But I'm really not sure.
North
Oh.
Carolina, they don't have any that much factory or manufacturer or
Well, they have a
is
lot of chicken factories.
they do?
Hmm.
Oh, okay.
It's like one of the number one chicken factory states.
North Carolina?
I went to two in North Carolina. There were one of
Oh.
them was producing organic Costco chicken.
Mm.
So yeah, no, they have a lot of variety of industry there. Do they have mining? They might even have mining still.
Okay.
I think that's mostly West Virginia, but
So this is the amazing data they gave us. And
Wow.
basically,
Is it there? Is oh, okay, it's not.
yeah, it's in this it's in our folder with
Oh, okay.
Octonauts
Here.
paper
Uh-huh. Uh-huh.
and go into the spreadsheet, obviously.
Mm-hmm.
It's uneditable because I would just keep it that way for now. Basically, this is like what they did with our legends, right? So what really mattered for us is profile name. The pretty name talks about the chemicals, obviously. And the
Mm-hmm.
chemical emission is the value we're interested in. So what we can do by tomorrow is for all of our
What you can do, Jin, you can copy it's original because I really don't want to mess up. You can copy one of them, and then different name and then editable. So the
yeah,
kids can
but no
edit.
one needs to edit this though.
Oh, really? I
We
thought
just
it's
need to
like
copy
manipulated.
paste. Cause yes, all we really need are these three. I could just, all right, I'll edit this a bit and get rid of all the second tier so it's less cluttered. But I'll drop it in the editable for everyone. No, I actually won't. I can just make another spreadsheet here
Right. Yeah.
because I don't want anyone being able
Right.
to
That's
edit
true.
this and you
Yeah.
can't just copy paste from a view only Google Doc or a spreadsheet. Actually, can one of you just Who's all right?
I tried copy pasting and it works just fine.
It works?
Yeah.
All
So
right,
you can
then
copy and paste?
Yeah.
yes.
Okay, great.
Yay.
Great.
Don't need to worry about any of these other ones. But basically what I want us to do is just take a look at this and change your emission values accordingly. And by that I mean copy paste. Please copy paste. Don't type it in. There's less room for error when you copy paste. It's pretty obvious how to read this. So profile name is AKA product categories, right? So for if you need to go find general purpose cleaners, I suggest you just Control F to find these. And then whatever you want, and only you'll get top tier. But like this is what we'll do by tomorrow, and hopefully we'll have better summations and be able to make that summation table we did similar to the frequency table. And I'll have this done tonight, so you guys can look at it later today or tomorrow.
Okay, so I'll see you guys on Monday.
Yes. Committee members will meet at 7 and the rest of us can meet at 8. And whatever we don't get done by 9, we can do over the weekend on our own times. I mean, at this point, we can push the committee day meeting a bit anyways. At this point, we're not going to miss out on much.
Okay.
So
I'm
we
gonna
can
check
think
Matthew
of
too.
it.
I will let you know. 7 o'clock.
Oh, okay.
Yeah, okay. Thank
Okay.
you. Thank you, Dr. Nas.
You're welcome.
Thank
Bye.
you.